Welcome to the next lesson on discriminants. This is the quadratic formula that we used before. Now we're going to focus on a part of it called the discriminant, and it's what's inside of the root sign. So the b squared minus 4ac is the discriminant because it discriminates among the types of possible solutions. So typically a parabola can have one solution, two solutions, or no solutions. That's where your graph will cross the x-axis. Now we're going to use this discriminant to determine the number of roots in the graph. But we're going to do this by finding the discriminant and then graphing the equation using Desmos to do that, to determine the number of roots. So we don't care about the value of those roots, you just know how many roots there are. So for this first one in the chart, we have negative 2x squared plus 8x minus 11. We need to determine what our a, b, and c is. So a is negative 2, b is 8, and negative 11 is c. Now we're going to plug those numbers into our discriminant formula, which is b squared minus 4ac. b is 8, a is negative 2, and c is negative 11. Now we're going to simplify this. 8 squared is 64. 4 times 2 times 11 is 88. And we need that negative there because that's negative times negative times negative. So this is negative 24. Now we're going to go into Desmos and type in this equation, but we're actually going to only type in the expression. So do not type in the equals 0, just the negative 2x squared plus 8x minus 11. So here's that graph, and by the looks of this graph, we don't have any roots at all because the entire graph is below the x-axis. So this means we have no roots. So you can say none here, or you can also say 0. Let's do the other one together. We don't have a number in front of here, but there's an invisible one, so that is your a. Your b is going to be positive 6, and then we need to move this negative 4 to the other side. So it becomes positive 4, and that will be your c. So if you want to rewrite this, it's going to look like a squared plus 6x plus 4. Okay, so your a is 1, your b is 6, your c is positive 4. Putting this into the formula, we have 6 squared minus 4, a is 1, c is positive 4. So that's 36 minus 16, which is 20. Now we're going to graph this to see how many roots there are. Here's the other one. Okay, so it looks like we have 2 roots, 2 points where we cross the x-axis. Again, we don't care about what that numerical value is for those roots. We just want to know how many there are. And we have 2. So I want you to go ahead and fill in the rest of this table. Find the discriminant of each. And then afterwards, state how many roots there are by using Desmos. So I didn't find the discriminant for all of them. I just merely stated if they were positive or negative. Because it seems like we get a pattern that if we have a negative discriminant, we're going to have no roots. And if we have a positive discriminant, then we're going to have 2 roots. So majority of them have none, except for this one over here that has 2 roots. So you want to check your work there. And then what did we notice? Well, we noticed that if we had a discriminant that's smaller than 0 or negative, then you're going to have no roots. If you have a discriminant that's greater than 0, then you're going to have 2 roots. Now, what happens if your discriminant is equal to 0? Then we're going to have 1 root there. And that's summarized for us over here. The number of roots of a quadratic equation can be determined by the discriminant. So if your discriminant is positive, you're going to have 2 roots. If your discriminant is 0, you're going to have 1 root. if your discriminant is smaller than 0, you're going to have no roots. So we're going to find the discriminant in example 1 and then determine how many roots there are. So this first one, -2 is our A, +3 is our B, +8 is C. And our formula is b squared minus 4ac. So b squared is 3 squared, a is -2, c is 8. 3 squared is 9. 8 times 4 times 2 is 64, and negative times negative is a positive. So we have 73 as our discriminant. This is greater than 0, so we have 2 real roots. For this next one, we're going to move the 9 to the other side by adding both sides of 9. So A is 3, B is -5, C is 9. We're going to put into our discriminant formula. That's -5 squared minus 4 times 3, because that's our A, and our C is 9, which is 25 minus 108. This is -83. So it's negative, so this is smaller than 0, which means we have no real roots. Lastly, for C, we can plug this in as is into our discriminant formula, but it probably would be easier if you didn't have a fraction. So what we can do is get rid of this fraction by multiplying both sides by 4. You don't have to do this, but it will be easier. All right, so this will become x squared if I do 4 times 1 over 4. 4 times 3 is 12. 4 times 9 is 36. 4 times 0 is still 0. So A is going to be 1, B is going to be -12, and C is going to be 36. So we have -12 squared minus 4 times 1 times 36. That's 144 minus 144, which is equal to 0. So if it's equal to 0, that means we have one real root. And our last example that's kind of different. We're given an equation and we're looking for the value of k, but we know that the discriminant will be greater than 0 because this quadratic function has 2 real roots. So our discriminant has to be greater than 0 for there to be 2 real roots. Now we're going to fill in some of the information we do know and then solve for k. So B is -5, A is 3, C, we're just going to call that k. So this is an inequality we need to solve for. We're going to square this -5 squared to get 25. 4 times 3 is 12. Now I'm going to move this 12k over to the other side by adding 12k to both sides. So then we have positive 12k on our right side, and then I'm going to divide both sides by 12. So your final answer is 25 divided by 12. If you want, you could also change this into a decimal, and this will be 2.083 repeating. So your value of k has to be smaller than 2.083, and that would be your final answer. So that's it for this lesson. Please check your homework to see what is assigned.